This video, let's talk about BellmanFord algorithm. We will talk about how BellmanFord algorithm finds the negative edge in directed graph. Finding negative edge in directed graph is an important application. For example, finding negative edge in the currency trading could earn us money called arbitrage. So we start from 1,000 US dollars. We trade that 1,000 with Canada dollar, and we trade that Canada dollar with Japanese yen. Then we trade that Japanese yen back to US dollar. Sometimes we will earn money. That opportunity is called arbitrage. This is a program allow us to do the arbitrage. Let's remove what we already have last time. Let's create this arbitrage. Compile this and let's run it. Okay, and you see it prepare the trading rates for each currency. Then it finds the currency which allow us to gain money. We start with 1,000 US dollar. We trade it with Hong Kong dollar. Then this Hong Kong dollar is traded with Japanese yen. Japanese yen is back to the US dollar. We gain 62 cents. This 62 cents is not too much for one trade, but how about we trade it for 1,000 times? That gives us $620. We could trade like 10,000 times. We don't have to do that manually. We can write a program to do the trading. And the program could do like 10,000 tradings each day and give us $6,266. And so let's see how this program works. Our starting point is to find the rates for different currency trading. There are many websites that provide us those rates. This is a website that provides the rates for free. It may not be the latest and the most accurate, but it gives us an idea. Like the euro can trade with those currencies. I don't know what this is, AMD, but that symbol could give me the rates for AMD. If we go to that web page, these are all the trading rates for that currency called AMD. I don't know what it is. But for example, I'm interested in these rates. That's great. I need a paper to write it down. Then I'm interested in this rates. I need a paper to write it down. You see, I need a list. The list header is AMD, and the rates is ARK at 0.019, and second row is BSD at 0.0205, and I can have other elements in that list. And we don't need a paper and pen to record those. We can write a program to do that list for us. And if we look at the inspect these elements, the HTML code shows us the rates we saw is from this field, right? And those field is actually inside a HTML web page. So if we look at the page source, the page source actually tells us everything we saw in that page. Those tabs have the rates. For example, here, this is for algo trading. This is another, for example, ANT. The rates is this one, and this is ARS. The rates is this one. So let's do use a curl to download that page. You see, we just download that page to our local, and we can parse out those interesting values in that HTML code. And we can write a Java program to do that. Let's see. We have this, and this is currencies we are interested in. We are not interested in all the currencies just because there are just too many. If we are trying to build a huge diagram with all the currencies one-to-one pair, that will be huge. We don't have time to do that, so we just interested in those few fields. So those currencies, for each one we could get into a web page and find all the trading rates with the rest of the currencies, right? So we do that with a helper class, simple rate cropper. And the simple rate cropper is looking for rates in this kind of HTML code. So what we do is we iterate through the currency. For each currency code, we do this curl command and download the HTML. We convert that HTML page into a string. So get a rate page, go back here, return us a string. That string is iterated through. For the rest of the currencies, we want to find the trading rate with the current one we are concerned with. Okay, you see, if the arbitrage is not equal to the current code, which is the current code with the current code, the trading rate is 1-to-1. So we are not including that. We only concern about the current rate, current currency with the rest of the currencies. So in that web page, we are particularly looking for this kind of a pattern. This pattern, once we find a match, this is a field we are interested in this brackets. And we capture that regular expression group. And the value is used to generate a map from the current currency to the rest of the currencies. We loop through each of the currencies and we generated order rates to the concerning currency. And the get rate, as you can see here, we have the rates map. The get rate, we iterate through all the currency. For each currency, we get the rates, right? We get the rates, and we generate adjacency set for that particular rates. For example, USD, we generate an adjacency list for the trading with Canada, that's one record, Euro another record, CNY another record, BIT, Hong Kong, JPY another record. Then we go to another currency like Canada, and we loop through again. We add its adjacency list, USD, Euro, CNY, BTT, Hong Kong dollar, JPY. At the end of the loop, we just generated the edge-weighted digraph. One thing to mention is we make the logarithmic calculation for the rate. The rate is positive, but after calculating the logarithmic, it became negative. So this digraph have negative edges. If we pass that digraph into BellmanFord algorithm, BellmanFord is able to detect the negative cycles. Once it finds it, it prints us the currencies involved in that negative circle, which is our arbitrage opportunity. Okay, BellmanFord. This is a BellmanFord. A quick introduction about BellmanFord. BellmanFord is trying to relax all the edges. After V relaxation cycle, if there are still edges need to be relaxed, that means there are negative circles. and it will find it. If all the edges is converged before V loops, then BellmanFord give us shortest path to all the nodes in the diagram. Okay, the rest of the code is just do the BellmanFord. We just see how the program works, and let's take a look at the result. The most important part of this program are those rates. Those rates is provided by this website. Sometimes it's not accurate, sometimes it has delay. When we see those rates, we go to the trading platform trying to do the trading. The rate could already change, or this website didn't provide us accurate rates at the first place. There are better information sources such as Google Financial or Yahoo Financial, or there are paid databases providing us provide those trading rates in real time, but those are paid services. And also scraping the rates from Yahoo Finance and Google Finance is harder than scraping rates from this website with plain HTML. But the most important part is those rates. Once we have those rates, we can create a diagram, and BellmanFord will be able to find us this money earning opportunity, and we can take advantage of it by trading it many times and multiply the 62 cents into thousands of dollars per day. Okay, it's some bank probably already doing that. They have a better machine and have optimized BellmanFord, but basically underneath they are using BellmanFord to find those opportunities and do those tradings.